Yes, sir.
So we stopped with yesterday with we stopped with an example of a loop. Yeah. So the next thing that we'll do is this is limits. So say sample arrays, or maybe arrays. Exactly. Yeah. I hope this doesn't conflict with anything. Okay. So the next thing that we'll do is arrays, and let's delete everything. So an array is basically a derived data type. Derived data type means it's obtained from the fundamental data types, say like integer, character, float, etc. And basically, yeah, all this is a recap. You must be knowing what these are already. And so, just 1 second. Well, let's yeah. So the first thing is to define an array, like all variables. So how to define an integer array? Tell me. What to write?
So you have to first write the kind of data it will be storing. So if it's integer, you write int.
Okay, int.
Then you write the name you're assigning to the array, and you also have to mention the size.
Size, how will I mention?
So in square brackets.
Okay. Say 8. And then what should I do? So if I can define this here itself, right? Maybe it's an so this means it's an integer array of 8 elements, and I can say that 1 2 3 4 5 6 7 8. Is that okay? I mean, let's check if it's okay or not. C++. Yeah, compiling. So this is a way to define. Does it work if I if I take the value of I mean, so here it's like explicitly the number is given. If I want this size to be a variable that I get from the user, is that permissible? Let's check. So this is array 1, and say int size in size int array 2 size. Okay, we're good. So size depends on input from the user. So this wasn't, I mean, in earlier versions of C++, you would have to do an explicit dynamic declaration for this using pointers. I don't know when this changed really, like around 2 years ago, while like in an AI class, I found out that yeah, all of us wished for such a simple dynamic. I mean, so like kind of, what do you call, implicit dynamic declaration to be available, but yeah. So we have this, okay, and then we can fill this up, right? So say 1 to the size if we want, maybe int counter equals to 0, and okay, so let's forget this for a while. The point to remember is that okay, so the nth element of the array, I mean the ith element of the array is denoted as, so the, this is like, yeah, the point to be remembered is that this particular cell which contains 1, so basically the array has 8 cells, okay, and the cells are indexed from 0 to n minus 1, where n is the size of the array, and we can access the ith cell by writing the name of the array and then the index in the third bracket. So this we can do, and then the last element also we can access. 7. Oops. I have a scene here somewhere. Okay. Anyway, so this is the 0th element is 1. The last element is element 0 is 1, and element 7 is 8. Let's forget this one as well. And okay, what happens if we do this? Yeah, 1 second, let's extend this. So basically we can see that yeah, we are accessing parts of the memory that are storing junk values, okay, and this will continue pretty much. What if I give 19 here? Okay, so it's accessing random elements from the memory, okay, which are junk values. So be careful not to go beyond cell n minus 1, where n is the size of the array. Okay, so now when we know the size of the array, or like we have even input it, then it's easy to so if you have a formula to fill up the array, then you can do it via a loop, and int counter equal to 0, and we can say that while counter less than size 2, counter is equal to let's say counter plus 1, and here we can say counter plus plus let's also, okay, we can also display the array like this. Let's put counter equals to 0 again, and we can say that cout array 2 counter yes, okay. So these notations are, you can use anything like this, it's the same, or you can say plus plus counter okay. However, I want to use, I usually use this just because, I mean, somehow I like the aesthetics of this statement, but okay. So let's look at something. So plus plus counter, I mean plus plus variable name, it increases the value of the variable by 1. Variable name plus plus increases the value by 1, and variable equals to variable plus 1 also does the same thing. But okay, counter is equal to 0. Cout counter, and there needs to be one index here. Okay, just let's, instead of scene, I will say just int size equal to 5. Let's put along several handles here. So this should output, this should print 0, that should print 1. Okay, fine. Yeah, so 0 and 1 we have got as expected. Let's again 0 and 1 as expected. Wait, what just happened? Why is it 0 and 0 this time? Anyone?
Because it first prints the count value and then it prints.
Yeah, because when it's when you're using the plus plus notation and you're running cout on the variable, then first the initial value of the variable is printed, then it is incremented. So if I do this again, now the incremented value of the variable will be printed, which is 1. Okay, and right, so this thing can be, let's see, let's copy paste this part. Say size equals to 5, that's fine. Counter equals to 0, and I'll make this array 3. Let's make it float. So floating point array 3, and 3 is okay. So let's say will this work? And all right. Oh, it's become an integer because we are doing stuff on. Wait, but it's 3 is okay. Maybe we should do something else. What if so we have actually we are using an integer for this calculating the I mean for inputting the value here. So though this array is array is capable of taking floating point in numbers, it is taking an integer. So what if we say float counter 1 is 0.0 and we do this. Semicolon was missing. Yeah, fine. But wait, so I'll have to do this thing. Counter 1 plus plus. Okay, we are all good here. That's fine. So floating point array, and what about character? Yeah, perhaps for yeah such a loop thing you can maybe use an ASCII code anyway. So I don't remember it. Character 4 size, let it be size 4 is equal to A, B, C. D. That's enough, and we can say that handle is needed. All right, so these are fundamental kinds of arrays, and then so these are only single dimensional, that is right. Above are only single dimensional arrays. Yeah, so the thing is that instead of having single dimension, we can have multiple dimensions. For example, if you have double dimensional arrays, you can look at it as a matrix. So yeah, so maybe integer add 3 by 4, and then we can just say So since this is multiple dimension, to initialize this, we will need like the number of loops. The number of nested loops is the number of dimensions, and let's say counter. So let's say CTR, because I don't want to get into conflict with what we have done before. 1 is equal to 0, CTR 2 is equal to 0, and then while CTR 1 less than 3,
So CTR 2 less than 4.
thank you. Right, okay. So should have a, okay. And see out. Okay, so this is your matrix. And finally, an implementation of arrays. So let's save as, which is this saved as it is? Okay. Right. Okay, so let me say this is all right. Int size equals to what? 20, and so now I would like to fill this. Okay, so in real life, the arrays will contain some important data, but here we can do with random numbers, and int counter 1 is equal to 0, and while CTR1 less than size. Yep. So I want this to have some random integers. What do I do? Yes. For putting a random integer, so I think this range function should work somehow. Huh? Let's see whether this is the one or not. Something like this goes through. Okay, but how do we know? Yes, so 20 random numbers. But we want to make life simpler, so maybe so this has a huge range. Yeah. So maybe
Sir,
find
I
it.
think we can give a rand parameter of n, so it gives between 0 to n.
Yeah, that can be done. Yes, but if you do this, so this is the remainder function, right? If I want between say 0 to 99, I can give mod 100 also, because then I mean then it is supposed to
Yes,
give
sir.
between, I mean let's see whether I'm right or wrong. You can always run your code. Okay, this is fine. Right. So I would like to sort this with a loop. So two loops rather. Yeah. Simple sorting. Um, I forgot actually which one is selection sort, which one is insertion sort. So one is supposed to be bubble sort, and that is like you keep on bubbling up some elements, and yeah. So let's take again counter to 0, and then what to do? How do I start a bubble sort? First, yeah, there will be an overall. So yeah, firstly we'll take element 0 and element 1, compare, whichever is greater shall go to the index 1, then this index 1 and index 2 will compare, and so on. So please guide me, what should I write? Yes, so maybe, yeah, I don't know what to write, but let's uh, yeah, this should go above. While counter 1 less than size, what should I do? So let's try to do it in another way. So bubble sort. If I am okay, so like after I iterations, I've done I iterations means see, first iteration I bubble the maximum element towards the right. Second iteration, the second max element towards the right, and each time I'm going. So first time I'm traversing all the elements, but then I've already I put the maximum elements at the end. So second time I'll traverse only till the penultimate element of the array. So what should it be?
size minus CTR1.
Sorry? Anything here? Anything here?
So
Sir,
you can
here it
define
will be
age
size
into
minus 1.
Size minus 1.
Size minus 1, okay. Then no, like I'm asking you to do the whole thing. So there will be two loops, yes? Obviously two loops. And how should it work?
So we need a second counter for the second loop first. And after that, it'll
What to do?
I think someone had said it before also. So in the second loop, you'll basically go up to size minus
This
CTR1 minus.
size minus?
Well, so it goes up to size minus
Okay, okay.
CTR
Okay.
minus
So this
1.
will be 0 because each time we start from the extreme left, and this will be CTR2 less than size minus what? Counter 1?
Yes, sir.
Yes, sir.
Counter 1, okay. Because the number of iterations is like the number of elements that we have already put in the extreme right of the array. Then what do we do? Someone else maybe, other than the voices I'm hearing often today.
Sir, if array at CTR2 is less than array at CTR2 plus 1, switch.
If this is array 1, okay. Array 1 CTR 2 is less than CTR 2 minus 1.
No, sir. Array 1 CTR2 is greater than array 1 CTR2 plus 1. So because CTR2 is 0, so
No.
Index
So
will be in this case.
bubble sort for ascending order. Okay. So if this is okay, if this is less, if the later, I mean, if the next element is less, then we have to switch, right? Because if the element, the first element is less than the next element, then we are all right.
no, sir. I was just saying that then you should start CTR2 with 1.
CTR2, okay, yes, right. Yeah. Okay. So then we can say that we need one extra variable. Temp is equal to let's make this okay, and then is CTR 2 plus plus and CTR 1 plus. Is this all right, or let's let's see how it works. No, it has not worked. So where are we going wrong exactly?
Sir, it is printing the initial array also below and the sorted.
Sorry. Okay, right. Yeah, then right. Okay, so it is all right. So this is okay. The bubble sort algorithm. So this takes what? Like above takes order n squared time. Now what if we want to do this faster? Merge sort. Yes. So merge sort, can you implement it using two loops? You all know the merge sort algorithm, right? Yeah, you divide the array into two halves and do a recursion on the two halves separately. So now you have two sorted arrays. Then you merge them in linear time. Can you do merge sort just using two loops, or you need something else? Yep.
So we'll have to use recursion.
Yeah, and what do you need to usually? What do you what do you need to use recursion? What do you do? What is the convenient?
So
Yeah, yes.
it's a function that calls itself basically.
Sorry, what?
So we make a function which basically calls itself.
Yeah. So this brings us to the next topic. Yeah. Okay, so we'll see some simple example. So our next topic is functions in C++. So perhaps some there must be some way to write a merge sort inside your main function itself, but as you write more and more complicated programs, writing, I mean, this main is large enough. Yeah. So as we go along, writing everything in the main body becomes cumbersome and confusing. So we'll start writing functions. Yeah. So functions are, I mean, portions of the standalone portions of the code which work on given input, given arguments, or sometimes they might not need arguments at all, and they can return or print certain values. So yeah, we have this already one function, and as so we'll follow the syntax of the main function itself. So function 1 like this, and say it returns 1. This is, I think, this should be okay, or are we missing anything? Let's check. That's fine. And what does this program do? It does nothing. But so if I say, let's see, I will try to, so this returns 1, right? So if I call this function, I mean, if I say cout and call this function, then what will happen?
Sir, func1.
Okay,
No,
func, yes. Okay, so it's printing 1. That's fine. So function taking no argument. We can define another function in sum. This takes integer a, integer b, and we can say that so cout sum 3,4. Okay, so now let's do something more meaningful. As one of you said, recursion is a function that calls itself. So the first such recursive function that I can think of course, the Fibonacci series. So what should I write? Int Fibo, int n, what should I write? So Fibonacci series, let me define Fibonacci series. Fibonacci series. So f1 equals to 1, f2 is equal to 1, or someone will start from 0 and 1, but let's keep it like this. f3, so and then I can say fi is equal to f I minus 1 plus f I minus 2. So the series goes like 1, 1, 2, 3, 5, 8, 13, 21, then I think it's 34, 55, and so on. Okay. So this recursion, how will I do it?
So first you can have the base case as if n is equal to 1 or 2, then you can return 1.
Okay, if n equals to 1, sorry, this is n equal to 1, or n equal to 2, return 1. Okay, then else
Then you can return Fibo n minus 1 plus Fibo n minus 2.
return Fibo. Okay, so let's for simplicity, let's put variable here. So maybe int var else var is equal to Fibo n minus 1 plus Fibo n minus 2, and return var. So if I say cout Fibo 5, what happens? All right. Yeah. Maybe something a little more. Okay, 55. That's our 10th value. Fine. All right. So is this an efficient way to compute the Fibonacci series?
No, sir.
Right. How much time does this take?
2 to the power of n.
Yeah, this takes exponential time. So yeah, the good way to compute Fibonacci series you will do on Sunday. Anyway. Right. And yes. So instead of doing this kind of thing, okay, so all these functions return integer values, but so instead of writing int sum this thing, yeah, so, so maybe in the main function somehow I don't want to write cout again, yeah, so I can do this, yeah, cout here. And since this is not returning anything, I can write void. So if I, so this is some print, yeah, some print. And then if I just write some print 5, 6, this will right. Okay, so we have learned the basics till functions, and we'll do some, I mean, not we, you will do some interesting implementations on the practice lab on Sunday, if you wish to come, of course. There'll be no attendance. And so next week we can jump to, no jump, actually we are doing things sequentially. We can do some things about pointer structures and classes, and we get closer to object-oriented programming. Okay, so yes, I'll see you on Sunday at 2 p.m. then, if you're interested. in coding practice. So those who have actually emailed me that they're weak in coding or don't know enough C++, I urge that you come on Sunday. Okay? Then we can have uh, an open practice session kind of thing. Okay, so till here then. Any questions?
Sir, in the lab, can you please give us a hint on how to solve that integer?
Sorry, actually there was a lot of noise. I could not hear. Can you? Yeah. Can you repeat or write in chat what you said just now?
So can you give us a hint or something how to do the lab question using integer arrays and multiply them? Like two numbers you are taking in the lab.
Previous
Two
lab?
large numbers. Yeah, in the previous lab we were taking two large numbers using arrays and then
Yeah.
we were multiplying those numbers. But
Yes.
how would we move forward with the algorithm by using only loops?
Okay. See, you have to take the elements as you have to consider the elements as single digits. Okay. So maybe the element, the integer 1000. That is, you store this 1 in the first position, 0 in the second position, 0 in the third position, 0 in the fourth position. Right? That is okay. Fine.
Yes, sir.
Now exactly you code the algorithm that you use in your head while addition. So if you have two arrays, yes. So first of all, you go to the last index of both arrays. Okay. So I'm not talking about decimal now. Just say two integers you have stored in arrays. How do you add? So go to the rightmost index of both arrays. Okay. Then you add those two digits. Yeah.
So
And
basically we will have to do the brute force approach only by using carry forward and all.
yes, exactly.
But it would take large time complexity because in multiplication we will have if the digits are large we'll have to
Yeah,
give up for
I didn't ask about complexity. Yeah. So
yeah.
there's simple, not simple, but multiplication only. The algorithm that we use while multiplying, yeah, when we multiply on pen and paper, so that is inefficient. There's something which is much more efficient, but all that is beyond the scope of this course. Okay, I didn't ask for complexity. I just asked for arbitrary precision.
So for
That's
the algorithm which we use for exactly for multiplication which is not the brute force one, that also we can't implement in large numbers, right? Because if you are taking them as input as arrays, so
yeah.
we use divide and conquer algorithm for multiplication afterwards.
Yes. Yes.
But in arrays how would we do that also? I am not understanding it because we will have to write
So
many arrays and something, I don't know.
no. So there are two aspects to it. So for example, merge sort is divide and conquer, and for merge sort you need multiple arrays, right?
Yes, sir.
So say on Sunday, I will ask you to do merge sort without using more than two arrays. Yeah. So it is perfectly doable. Yeah. So that's so these are called in place algorithms. Usually it's the things for what you need many, a lot of different arrays. Those can be modified to have things in place, like not exactly in place, but some constant number of
So
data structures.
we are gonna use a temporary data structure which is currently storing the information and repeating again and again. That only, right? Hello.
I'm sorry, I did not.
We'll be using a temporary data structure which will store information only to not exceed. Yeah. Okay.
Okay. Yeah. So these are very interesting questions. Good. Okay, then, yeah, once again, the person or the persons who are recording these lectures, can you please make a folder and save the recordings? Yeah, that will be very convenient. Okay.
So they automatically come in the MS Teams.
No, but there is a